start simulation. Okay, it's finished. So let's check the S parameter again. Here we got our new S parameter. After zooming in, we can see the antenna will resonate at 2.4 GHz exactly. That's what we want. We can change it to linear, then mark to check the return loss here. Double click. At 2.4 GHz, the return loss is only 0.057. We can calculate this value. Here we can see nearly 0.34% power will be delivered back from the antenna to the transmitter, which means the return loss is very low and the transmission line efficiency is very high at the moment. Also, we could check the radiation efficiency and total efficiency in 1D result. Here we got radiation efficiency, total efficiency. The difference is total efficiency equals radiation efficiency times the transmission line efficiency. It's caused the difference caused by the impedance mismatch here. Also, we could check the VSWR. You can see at 2.4 GHz. VSWR is quite low, so 2.4 at the moment is nearly at 1.13. So if the VSWR equal to 1, which means 100% power, all the power will be delivered from transmitter to the antenna. But that's the ideal case. Also, we could see some interesting results like how the E field changes in 2.4 GHz, or we can check how the H field changes here. I think these functions are very interesting because HFSS doesn't show much like that. It's very useful for beginner to understand how the E field and H field change. Also, you could check how the surface current flows. We said the feed here is positive and here is negative, so the power you can see at the two ends of the dipole, the current is 0, and in the middle point is reached to the peak value. Also, we could check the radiation pattern of our designed Wi-Fi antenna in free space. Here we got the radiation pattern in 2.4 GHz. Here we can check the 3D radiation pattern. We also could check the 2D radiation pattern. It's very convenient. And it also shows the 1 GHz radiation pattern and 10 GHz radiation pattern. Okay, that's it. If you have any question about the video, welcome to leave a message in my channel. Thanks for watching. See you next video. Bye.
Hello everyone, I am Sassur Rahman Akash. I am doing this work under my respected supervisor Dr. Noor Hisham. Here is our objective. We will design a square patch antenna on a FR4 substrate. The frequency is 2.45 GHz and the thickness is 1.6 mm. And later on, we need to find the characteristics of the patch antenna. The dielectric constant is given as 4.7. So at first I listed down all the parameters value, like the frequency is 2.45 GHz, the dielectric constant of substrate is 4.7, the height of the substrate is 1.6, and height of the conductor is 0.035. Then I listed down all the formulas I got from different books from antenna designing. These are the formulas. Fi is the length of the feed line, and some information like the gap between the patch and the and feed line, usually 1 mm. Let me show you the feed line. Okay, this one is the gap of the patch and the feed line. This one is the feed line, and this should be 1 mm. This is usually. And here the input impedance is usually 50 ohm. It's usually 50 ohm, and let's say the microstrip feed line is showed by WF. This one is the width of the microstrip feed line. And C is the velocity of the sunlight. So now let's calculate the value of the parameters. At first we calculate the value of width of the antenna. So by substituting the parameters values, we could find the value of width, which is 36.27 mm. And as it is a square shaped antenna, so the length and width would be the same, so we get the length as well. And by substituting the value of h, which is the thickness of the substrate, 1.6, we can find the value of fi. Remember the fi, this one, we can find out the value, this one, as 4.8. So then we got the value of the parameters here, which is the width is this one, fi is this one, wf, which is the width of the feed line, is 2.92, gps is usually 1, and this one is the formula I got it from the book. Lg is 2 multiplied with L, Wg is 2 multiplied with width, and this is Ht, and this is Hs, and this is the outline we just draw to make ourselves easier, comfortable with this. So now let's design using CSK. This is the first window. If we open the CSK software, we will see this. Then we have to create a new project here, and microwave and optical. Then click on antennas as we're designing this. Click next. We are doing a panel antenna, so click on this. Tanjome. And here we need to define all the parameter units so that no complicated issues arise later on. So this is the parameter units we will use. Oh, now we have to find our frequency is 2.45, so our frequency range should be from 1 to 3. And these are the things we will like to see on our result. So let's just click on everything. And ours, we have this specific frequency of 2.45, so let's just define 2.45 here. Okay, next. Okay, finish. Yes, this is the first thing we will see. Okay, let's calculate the impedance first. As we already written all the parameters value here, we can calculate the impedance value from here. We are using thin microstrip.